Hey guys, this is Marga. I hope you're all doing good today. This would be our second video and we will learn about finding the angle between two curves. I hope you already watched the first video, and if not, check it out now, and after that, go back to this video. So again, before jumping to the examples for this topic, we will first define and know the principles of the angle between two curves. Now let's consider the graph here. The first line here is our first tangent, D1, and the second line here is our second tangent, D2. The angle between two curves at a point of intersection may be defined as the angle between their tangents at this point of intersection. This signifies the acute angle that forms between the tangents to these curves at the point where they intersect. For a general discussion of this concept, consider the two curves here, the first curve and our second curve, which intersect at a point, as you can see there. Let theta 1 here and theta 2 here be the inclinations of the tangent T1 and T2 at the point respectively. So let the phi here be the angle between these tangents. Then by definition, phi is also the angle between the curves. And again, this would be our curves here that intersect at a point because of our tangents here, our first tangent, and our second tangent here. And by the definition of the angle between two curves, phi here is the angle of those two tangents. And for us to be able to solve for the angle between the two curves, we could use this formula. Tan theta is equal to m2 minus m1 all over 1 plus m1 times m2 in its absolute value. And because we already know the angle between two curves, I can say that we are now ready to solve the problems that we will solve later on. So let's go. Now let's have our first example. Let's read it first. Find the angle of intersection in degrees of the curves y is equals to x cubed plus x minus 8 and y is equals to x. But before answering those, I need to share this with you first. The steps that I always do whenever I answer this, the angle between two curves. First is derivation, which you have the slope. Second is the point of intersection, and the third one is by using the formula. And then that's it. That's just how easy it will be. So let's go. So first, we will derive the given function to get our slope. Let's copy them first separately because we will derive them separately. So y prime is equals to 3x squared plus 1. We could denote this one as our first slope, 3x squared plus 1, so that it would be easy for us later to just substitute the x and y values. So next is the y is equals to x, y prime is equals to 1. So denote this as our second slope. It's equals to 1. So now for our second step, which is to find the point of intersection. So let's find the point of intersection of these two given functions. For us to be able to get either one of the values for x or y, we could eliminate one of them to get the other one. So since y is equals to x, we can input the y there as x to get our value of x. So let's do the operation. So x cubed is equals to 8, and then cube root that. So the cube root of 8, we all know that it is 2. So x is equals to 2. And since y there says that y is equals to x, and then our x is 2, so y is equals to 2. So our point of intersection here is 2, 2. And now since we have our point of intersection, we can substitute that to our slope 1 and slope 2 to get the slopes. So for the slope 1, for the first slope 1 is equals to 13. So let's put 13 there. And then for slope 2 is equals to 1 already. So yeah. So our first slope is 13 and our second slope is 1. So now let's proceed to our third step, which is use the formula. So let's write that there. And again, the formula. Tan theta is equals to... Wait, what's that again? Just joking. Okay. Tan theta is equals to m2 minus m1 all over 1 plus m1 times m2, and it's absolute value. Don't forget guys, absolute value, okay? So now let's substitute those slopes that we have. 1 minus 13 all over 1 plus 13 times 1, absolute value. So arctan (1 minus 13) is equals to 12 over 14. And we could still simplify the 12 over 14. So theta is equals to arctan 6 over 7. And this will be our final answer. Theta is equals to arctan 6 over 7. Yay! So again, let's see the steps that we have performed a while ago. First, we derive the given function and then get the point of intersection and then use the formula. Here, the first, the second step, which we get the point of intersection, it's substituted the slope to get the slope. And then third is using the formula to get our theta. And that's it. That's for the first example. So now, here's our second example. Don't forget the 3 steps here. So first, the derivation. Second is the point of intersection. Third is by using the formula. Let's go. But before anything else, let's first read the problem. Find the angle of intersection in degrees of the curves y is equals to x squared plus 1 and y is equals to x plus 1 over x. First step is the derivation of these two functions. Now let's copy them first. Separately. So y prime is equals to 2x. And we will denote this as our first slope. m1 is equals to 2x. And for the second part, 1 plus derivation of 1 over x. So 1 plus negative 1 over x squared. So that would be our second slope. 1 minus 1 over x squared. So for the second step, the point of intersection. So since they are both expressed in terms of y, we could say that y is equals to y to get the value of x. Okay. Then x cubed plus x is equals to x squared plus 1. Let's move them on this side. So x cubed minus x squared plus x minus 1 is equals to 0. And then factor this out. X squared times x minus 1 plus x minus 1 is equals to 0. So to proceed with the factoring, x minus 1 times x squared plus 1 is equals to 0. And now solve for x. So we could actually have a 2x, but the second x that we get is an imaginary x. So it would be difficult for us to use this. So let's use the other one. The x is equals to 1. So let's substitute the value of x to get the value of y. So our y here would be y is equals to 2. So the point of intersection in our problem would be 1, 2. This one. Now let's substitute this x and y to our slopes to get our slopes here and here. Okay, for the first slope equals to 2x. So let's substitute the x, 2 times 1. So for our first slope, it is equal to 2. And then for our second slope, 1 minus 1 over x squared, 1 minus 1 squared. So our second slope is 0. So that would be our slope. Then we will proceed to our third step, which is to use the formula. Don't forget the formula. Tan theta is equals to m2 minus m1 all over 1 plus m1 times m2 and on its absolute value. So let's substitute the slopes that we have. So 0 minus 2 all over 1 plus 2 times 0 on its absolute value again. So theta is equals to arctan 2 over 1 or simply theta is equals to arctan absolute value 2. So the answer of our second problem would be theta is equals to arctan 2. So let's see again the steps that we have performed. First is the derivation, which we performed correctly. Second is the point of intersection, the x and y, and then we substitute that to get our slopes. Here, that one there, our slope 1 and our slope 2. And then substitute those slopes in our third step, which is using the formula. Right here, there, and substitute, and then we get here, and then the final answer, arctan 2. So that's it. That's it for our second example. This is Marga, and if you find this video helpful, please like and comment down below and do subscribe and check out for my next video. Adios!